Kids. Today we're on the second day of our mole unit, and today we're going to take the same mole conversions that we learned in the last unit, or excuse me, in the last lecture, and we are going to do two-step mole conversions. So today our objective is going to be to apply mole concepts in unit conversions to two steps. And just to review the mole conversions that we did yesterday, remember we've got three sets of conversions. We start with mole in the middle, okay, and we can go to grams, which is mass, and we use molecular weight, remembering that the molecular weight on the periodic table is equal to 1 mole. And then we can also go to volume, which is in liters, and we use at standard temperature and pressure, 22.4 liters equals 1 mole. That number, remember, is on your yellow periodic table, so you don't ever have to memorize it. And then the third thing is if we want to go to particles, which would be molecules or atoms, okay, we would use Avogadro's number, which is 6.02 times 10 to the 23rd particles equals 1 mole. And again, that number is also on page 1 of your periodic table, your North Carolina reference sheet. Okay, so we need to know this mole triangle and how to use it to do two-step mole conversions. Okay, let's review our steps again. Okay, now in the last video and the last homework problems, we only used one step. So we either used steps 1 or steps 3, where we converted the given into moles, or we converted moles into another unit. Now today, we're going to be using both steps at once. Okay, so we're going to be using step 1 and step 3, where we convert the given into moles, and then we get out of moles and into a new unit, which would be liters, grams, or molecules. And once again, just like we did last video, we're not going to use step 2 yet. We're going to save that for our next video. So once again, we're going to use two steps, steps 1 and 3. We're going to use our numbers in our mole triangle and use our tool of factor label. Okay, so in your notes, you should have example number 5, okay? This should be, like I said, in your notes so you can follow along and write down. Okay, so number 5 tells you want to know what is the mass of a 256 milliliter sample. Okay, now I think in your notes I had already changed it to 0.256 liters. Okay, so let's just make sure we change that in my example here. What is the mass of 0.256 liters of carbon dioxide gas at STP conditions? Okay, so what's our given? Okay, well, it's usually the one that's got the number, so there's our given, 0.256 liters. And what's our unknown? What do we want? We want mass, okay, which is going to be, so our answer should be in grams, right? Okay, so let's follow our steps. Step 1 says you get the given into moles. Okay, so let's do our factor table. Let's put our given right there in that top left box. Step 1 is to get the given in moles. Okay, well, if I look at my mole triangle, okay, I am basically trying, this is particles, I'm going to try to go from liters to moles. That's my step 1 right there. Okay, what factor do I use? Okay, I know that 1 mole is 22.4 liters. So I got to use this first factor. Okay, liters is in the top left, so liters has got to go down here, and mole goes up here because my first step is to get out of the whatever given units I have and get it into moles. So then I put 22.4 next to the liters and 1 next to the mole, and that's going to cancel out my liters. Okay, now we've done that so far. You should be okay with that. Now we have to add a new train track because we're in 2 steps. Now my new given is moles, which means moles got to go down here. like factor label rules. Okay, so mole's going to go down there to cancel it out. And what do I want as my final answer? I want grams. So grams has to go up here. Now, if I'm going from moles to grams, what do I need? I use molecular weight. Okay, so what I need to do is 1 goes down here, and I need to add up the molecular weight of carbon dioxide. Okay, so we know 12.01 is carbon, and 16 times 2 is oxygen. And if you add that all up, you get 44.01 grams equals 1 mole. So 44.01 grams goes here, which equals 1 mole. So I've done now step 1 and step 3, where I first took my liters, got it into moles. Then my last step was to get out of moles into my desired unit, which happened to be grams. Okay, now be careful with your math here. Remember factor label rules. That's 0.256 times 1 times 44.01 divided by 22.4 divided by 1. Don't forget to divide everything on the bottom. And you get an answer, 0.502 grams of carbon dioxide. And that's your answer. So this was a good 2-step problem. Okay, now this one is a little different. This should say molecule. Okay, this is a little different, okay, in terms of, but I put it in here because I always see this problem on quizzes. What is the mass of a single molecule of carbon dioxide gas? Okay, well, we know we just added it up. Okay, if we want the mass of a single molecule, what we're saying is we want the mass per 1 molecule. That's the unit we want. Okay, and if we start out with the molecular weight, which we just added up in the last problem, so that is 1 mole. So if we want to go from moles on the bottom to molecules, all we have to do is divide by Avogadro's number. And we can get rid of these moles here and get to molecules. So this is going to be 7.31 times 10 to the negative 23rd grams per molecule. So that just tells you how much one molecule, one carbon dioxide molecule weighs. Okay, so this is not really a 2-step. This is really just a special kind of problem that I threw in there. Okay, how to figure out the mass of one molecule. Okay, now back to another 2-step example. How many carbon dioxide molecules are in the sample described in example number 5? Okay, well, in example number 5, we're going to start with the given data, which is 0.2568. Okay, so we're going to start there, and we want to know how many molecules. Okay, so the first step is to get out of the given unit into moles. Okay, so looking at our mole triangle, okay, the given goes here. Okay, got to cancel out those liters, so we use those on the bottom, and we want to given out a liter. Okay, and we know from the mole triangle, we use 22.4 liters equals 1 mole. That's the conversion. And now once we've canceled out the liters, and we're in moles. So our new given now, moles. So now this is our given. So we want to cancel out that moles and get into the desired unit, which is molecules. Okay, now to go from moles to molecules, looking at our mole triangle, we know we use Avogadro's number. So that's where that 6.02 times 10 to the 23rd, times 10 to the 23rd molecules equals 1 mole. Mole cancels out. Okay, and now we're left with molecules. So we've had our 2 steps.
Got to add liters into moles, add moles into the desired unit, which happen to be molecules. Now our math, 0.256 times 1 times 6.02 times 10 to the 23rd divided by 22.4 divided by 1. Remember, everything on the bottom is divided. And you end up with an answer of 6.88 times 10 to the 21st molecules. And that is the answer to this problem. Okay, and that's the end of this video on two-step mole conversions. And your homework will be to practice two-step mole conversions. See you guys soon.